Hello, everyone, and welcome to our SDC session, Why SAS is a Goldmine for Crypto. My name is Cameron Brett with the SNE SSD SIG and the SCSI Trade Association. Joining me is Jonmichael Hands, VP of Storage Business Development for Chia Network. Today's webinar will have an overview of Chia and proof of space and time for crypto farming, and why SAS is a really great technology for this type of crypto. Quick housekeeping item: if you have a question, please type it in the chat box at any time, and we'll try to answer your question real time during the session. Also, please provide feedback and rate this session. SAS has been the tried and true storage interface for data centers for decades. And according to Trend Focus, this chart shows the amount of storage capacity that will be connected via SAS through 2026. What makes SAS connected storage so large? SAS has the capability to connect SAS and SATA hard drives and SSDs. The majority of the SAS connected storage will be SAS and SATA hard drives, and likely that PCIe and NVMe SSDs will be preferred for fast SSD storage. Not only is SAS used in the traditional enterprise data center, it is used in hyperscale deployments where hard drives are used for vast amounts of data storage. Here's a quick look at the SAS and SATA and PCIe interfaces. On a single lane basis, 24 gig SAS provides a very high bandwidth, with the exception of PCIe 5.0. The bandwidth numbers here are at the raw interface level, accounting for encoding overhead. It doesn't account for protocol overhead. As you'd expect, 4 or 8 lines of PCIe will be the fastest bandwidth per device, but SAS still offers some very good performance options with SSDs. Here is a closer look at the actual connectors used for SAS deployments based on the generation of SAS. This may help you select proper cables needed for SAS architectures, so you use the right cable for the right generation of SAS. Also, I want to show the link at the bottom here where you can download the SAS Integrators Guide. It goes into more detail about cables and connectors and is a great resource for connecting up your SAS deployment. And at this point, I'd like to turn it over to Jonmichael to talk about Chia.
Hey, I'm Jonmichael Hands, VP of Storage at Chia. Chia is a cryptocurrency based off proof of space and time, which uses underutilized storage space to secure the network. So SAS has obviously been very popular in Chia because in Chia, you try to use the highest capacity and lowest cost media, which has the best total cost of ownership, very similar to archival storage, which today is on hard drives. And SAS infrastructure is very mature and has been around for a long time. So it's been very fun to take the SAS learnings I have. I actually started my career at Sun Microsystems out of college in 2008, designing a SAS JBOD. So I've been around SAS since the very beginning in SAS 6, but in that transition between SAS 3 and just SAS 6 gigabits per second. So it's been fun watching this. I'm going to give a quick overview of Chia and what are the proof of space construction and what we call farming. And then I'll go into how Chia application is used in different SAS topologies. So in Chia, we use proof of space, which basically a farmer is trying to prove they are allocating a certain amount of space to the network. Now, this space happens to be in something we call plot files, which is just random cryptographic hashes. And there's no actual user data or anything meaningful being stored. We actually use this as the means of consensus for the network to basically secure the network. In Bitcoin or something, every 10 minutes in Bitcoin, you have to basically do these cryptographic puzzles or proof of work. You can think of Chia in this: we do this puzzle once, these plot files, and then you write it to disk and you have it. It's kind of like a bingo card. And you can save that for later. And then challenges come in from the network. You basically scan your plot files in the background. You do the reads of the cryptographic hashes in there and see if you have any plot files that match the challenge. And if you find a winning proof, you can broadcast to the network and you can make the next block in the blockchain. This is how blockchains operate with the consensus. And we call this Nakamoto consensus, but it's really that there's no trust. It's completely decentralized and completely peer-to-peer. All a farmer has to do is look at the network, look at who has the longest chain. It's a complete peer-to-peer protocol, and then they can trust that chain. So there's no trusted third party. And this is the magic of how blockchains work. But you can do this all through storage space at very low energy and electricity costs, which is why Chia was invented, to basically kind of solve the problems of proof of work that consume a tremendous amount of electricity and energy to secure the network. And in Chia, of course, the farmers get rewarded today. They earn 2 Chia as a block reward for finding a block. So there's an incentive to put this underutilized storage space up to the network. Now, this is really good because there happens to be, one, a lot of underutilized storage space in the world. IDC has this report they call the storage sphere and data sphere, but the storage sphere basically is showing the entire storage install base of the world. And there's about, I think, 7.9 zettabytes of install base as of last year in all the storage in the entire world. And a very large percentage of that, about 3 zettabytes of that, is underutilized or available. So this is a great opportunity for us to basically take a asset and commodity like storage that's already underutilized and basically use that to secure the network, and then provide incentives for people to join the network. And so proof of space, basically, you just need to basically have a person that can prove they're storing a certain amount of data. In Chia, basically, the more storage you have, the higher percent chance you have of winning. It's very similar to hash rate in the analogous of in other cryptocurrencies, but we call it just network, or we just call it space, is how much space you have, and that's measured in number of terabytes or petabytes and whatever if you're going really big. So the one thing that these plot files, although they take up a lot of capacity on your hard drive, they need to be easily and quickly verifiable. You don't want to have to read a whole 100 gigabyte file to verify every time a challenge comes in. You just wanted to basically be able to do a few reads and make sure that they're there. And so you have to do some upfront work, which is called plotting, which is basically creating these proofs of space into this plot file. But that only has to be done once. And once that's done, that's copied over to a hard drive where the farming takes place. And that's this quick and easily verifiable proofs, where you're basically doing these quick lookups to basically ensure that the farmer actually is storing the amount of data that they're storing. And these plot files also have to be resistant to attack. So they can't be manipulated or can't be hacked or can't be faked. And that's part of why the plotting process is kind of this hard. Now, we're not going to go into the proofs of time in this presentation, but the proofs of time in Chia are basically to prevent a lot of these other malicious attacks. And this is one of the really interesting parts of this cryptocurrency that uses verifiable delay function. So this Chia plotting process basically is, I mentioned, you can do it through the GUI, you can do it through the CLI. But you basically need temporary storage space, or lots of DRAM basically to create these in memory. And you just create them. And once you use this one-time compute, you just copy them to the hard drive. So this process of copying, definitely requires bandwidth to the disk. Usually you're limited to like the amount of storage speed that a single hard drive can write at, which when the hard drive is fresh today, hard drives can write at about 270, 280 megabytes per second at the beginning of the tracks, and go down to about 130 megabytes per second at the very end of the drive. But now if you do that across 30 drives or 90 drives, now all of a sudden you need a lot of bandwidth. And this is where SAS comes in. Each of those SAS cables for 12 gigabits per second contain 4 SAS links that can do bidirectional bandwidth of up to the single, 4 times the amount of bandwidth of a single lane of the SAS, which we covered a few slides ago. So that's really exciting. I have this picture and I have the title, "What's Wrong with This Picture?" So basically, there are a lot of people in crypto that crypto drives to these very low cost solutions. In graphics card mining in Ethereum, they drove these weird kind of adapters between, there was HDMI and there was USB from PCIe, because PCIe cabling wasn't very mature and it wasn't low cost. So people just kind of came up with whatever solutions they came up with. Now in Chia, there's people that have tried these low cost storage solutions for high number of drives for a very long time. And it's very challenging because, if you want to store a large amount of drives, you start to have other issues. And when you have a board like this, and this may be, I think this is a kind of an older Intel chipset, and they like these in China, I guess, because you can get these like older Intel CPUs like on the secondary market. But you're missing a few key points. One is when you have this many drives, you need what SAS calls enclosure management, a way to actually manage all these drives in the slots. So the slots have numbers and the slots have orders, and you can basically know what is inserted into that slot. And then the other things that SAS expanders actually understand are stuff like fans and power supplies and other things you need to basically pay attention to when you're monitoring. So you can think of like in SAS JBOD, which is a common element for large scale Chia farmers, which is kind of, we covered this in the farmer types. You have these large farmers, which are basically, these hundreds of terabytes or even petabytes, that now you start moving away from desktop NASs and desktops or NASs to kind of JBODs and enterprise equipment. And the reason for this, you can see here, I have a picture of SAS enclosure management. So this is an example of actually me using SAS enclosure management in practice. So one of the things we do for Chia is make use of used and recertified drives. And this obviously, I mentioned, Chia doesn't store any user data, so it's a very good target for used storage that doesn't have as high quality or doesn't have storing very important user data. And I'll talk later, you don't need redundancy or RAID or anything like that in Chia. But because you're using some used drives, you basically sometimes have to monitor drives for failures. Or, in my case, this is scanning some recertified drives for reallocated sectors. And when I find a drive that has reallocated sectors in Linux, when I'm doing the smart monitoring, I basically can do this LED locate on the SAS JBOD and find a slot which has that bad drive. So what I will do is I'll do a smart control. I'll find out the drives that have reallocated sectors. I will find the serial number of that, and then I'll use the SAS enclosure management to figure out which slot that actual serial number is in, and then I'll turn on the locate button. And that locate will blink the LED like this, so I can go out to the server, go to the JBOD, open it, and pull out the drive that's actually broken. Now in SATA, again, this is not possible, right? You have to build all these other stuff on top of SATA that's not native to the protocol. And there are some people that have made these SATA enclosures like NASs that had to recreate all this stuff in software with LEDs and management and stuff. But this stuff is all built into SAS with enclosure management. So this is why JBODs are really nice. For one, it's just the quality of life. You have the fans, the power supplies, of course, JBOD, just a bunch of disk. It's storing as much data as you possibly can in a small amount of space. In this case, we have a 4U enclosure that's holding 90 drives, so you can get very, very dense storage, and then have lots of flexibility in the management and cabling, which is what we're going to explore next. So one of the common elements for Chia is this plotting. I mentioned, you definitely are only doing this once, and so in this Chia, maybe you have a farm that is lasting for 5 to 7 years, and you'll have this 2 to 3 month phase where you're plotting. You're actually doing the initialization of the farm. You're setting up these proofs of space. When you're doing that, you're creating these plot files, and then the goal of that is to move them as fast as possible to disk. And so the way to do that, as I mentioned, is to do that in parallel. You make a bunch of plots very fast on the server. Now, doing this all on DRAM is the fastest way to do it today, where you can use high endurance NVMe as kind of this temporary storage. But then you have basically one SAS HBA connected to these JBODs, and you can allow one SAS 12 gigabit per second cable offers 4.8 gigabytes per second of bandwidth. Now, I think in practice, and with the overheads in reality, you see kind of close to like a little over 4 gigabytes per second I see in actual practice. That's just with one cable. And so that's really helpful because now, I mentioned one hard drive is only 270 megabytes a second. So now you can write to many, many hard drives in parallel without bottlenecking the system. Now, one of the really interesting features that SAS has that we actually are able to take advantage of with Chia is this thing called zones. Now, zones has lots of meanings in storage now with zoned storage and zone namespaces and shielded magnetic recording. They also use the word zones, but this is completely different zones, not to be confused with. Fortunately, this came first, but there are multiple uses of zones in storage. But a zone in SAS, in a SAS expander model, remember SAS expander is this element that basically takes one target and basically it makes it you can access many more targets, similar to a switch. And there's lots of SAS expanders in these JBODs. So you can set up these, you can set up the JBOD for different types of zoned configurations. One of the configurations I'm showing you is with 3 zones, where you have in this element, and again, I'm showing this picture of this because I'm very familiar with this JBOD because I own a few of them. You can set up this, you can set up the JBOD into 1 zone, into 2 zones, into 3 zones, and then you can assign each port on the back of the SAS expander on the module to whatever zones you want. And in this case, it's showing, port A is assigned to zone 1, port B is assigned to zone 2, port C is assigned to zone 3, and then port D, you can access all 3 zones. So I'm going to show you a setup where this is actually really interesting. In the plotting phase, again, the goal is to fill up the drives as fast as possible. And so what you can do is have a multi-server setup where you have each of these servers creating these plots in DRAM and then copying the files sequentially over to the JBOD. Now, if you have 90 drives attached to one JBOD, and you were plotting with multiple servers, then you'll have to basically copy those files over the network, over like a 10 gig network, to that one host, and then copy it back over to the expander. And so that's obviously a bottleneck, because I mentioned one SAS 12 gigabit per second cable is able to do 4 gigabytes per second of bandwidth, while one 10 gig port is only able to do 1 gigabyte per second of bandwidth. So this SAS cable in this instance, one SAS cable, which is very inexpensive, $10, $15, something like that, is able to do 4 times the bandwidth of a 10 gig network link. And so this is really helpful for this plotting phase, where it's much cheaper to do this than it is to have high-speed networking and enterprise-grade networking switches. You can just basically have these hosts with a host bus adapter connected to each zone in the expander, and each one has full bandwidth to 30 of the drives. And this is basically the fastest way you can possibly do this plotting with this multi-zone setup. And I've done this in actual practice, and it works, very well. And then you can manage the hosts independently. So each of these hosts only see 30 drives. It's almost like they have their own mini JBOD, but you have all the drives in one nice place where you can manage centrally. Again, with one set of power supplies and fans and all that stuff. So this is a very convenient setup for what we call plotting. The next phase is what we call farming. Now, in farming, the goal of farming is just to store the most amount of data in the smallest amount of space at the lowest power at the lowest cost. And in enterprise storage or hyperscale storage, this is called TCO, total cost of ownership. And so it's no different in Chia. In Chia's this farming is very competitive, and so you want to be able to store a massive amount of data in a small amount of space, and JBODs do very good at that. Now, the really cool setup for farming in SAS topologies are SAS expanders allow this thing called cascading, where you can actually basically have one cable from a host server to the JBOD, and then you can have another cable from one JBOD to another JBOD. And then that one host can access all the disks. And you can cascade basically as many, I think one expander can do 256 SAS targets. So you can basically just continue to keep cascading until you basically hit other bottlenecks like software limitations. But this two cascaded JBOD topologies is actually very common for Chia, like a high scale Chia farming, because once you're farming, you don't need very much compute. You just basically need to attach all the drives, and there is a very small amount of IO that needs to happen. And I have a slide here and a couple slides that will show that. But the farming is very lightweight. It's just a few IOPS, and actually on the drives, it's less than 1 IOP per drive. So the total load is very, very small. So you basically just want one cable, and you want to hook up as many drives as you possibly can with that single cable. And that's where this multi-JBOD cascaded topologies come in, where now you can hook up in 2 of these JBODs 180 drives with one host and one cable, which is absolutely amazing. And it's very common in hyperscale configs, in archive storage, for instance, to hook up 3 or 4 large scale JBODs with expanders and with one cable from one host, because they don't need very much compute in archive storage. They just need to store the data, and it's colder storage that's infrequently accessed. So, all right, what is the difference between SATA and SAS hard drives? Again, SATA and SAS hard drives, they use platters, they use rotating media, they're 7,200 RPM. They're actually very similar underlying technology of how the data is read and written. The difference, obviously, is the host interface. SAS is faster. Now, you have hard drives that have SAS 12 gigabits per second for 6, but that doesn't change the underlying limitations of bandwidth on the storage media. SAS, of course, is high availability. It has dual ports. So the key difference between a SATA HDD and a hard drive is SATA was designed to be single host, single target. And again, this was designed to be for laptops and for desktops, and it'd be a very inexpensive cabling, right? A SATA cable is like 25 cents, 50 cents. This has been, this is the main purpose for SATA, is to be cheap kind of consumer all around storage, where SAS is really the enterprise grade storage that had support for high availability, dual ports, faster speeds, multi-host, multi-connection. So with the dual port, you can have multiple hosts targeting the same drive at the same time with different data. Now, of course, you need file systems and software that supports this, but the SAS protocol natively allows for different hosts to access the drive at the same time. So this is the main difference. Of course, there's tons of different functionality. SATA has smart, where SAS has logs, and those things are different. But again, they're very similar. Of course, they have to report stuff like reallocated sectors, like temperature, and all the other things that hard drives manage. So for Chia, the answer is whatever one is cheaper at the time, right? Which may be old SAS drives that enterprises are getting rid of. They're still high capacity, like between 10 and 14 terabytes. That's still very, very good for Chia. And enterprises may not need anymore, or high capacity SATA drives. Again, people are using used and refurbished drives and recertified drives as kind of the primary use right now. Because that's the most competitive for Chia farming. But really, for Chia, all that matters is high capacity, low power, and low cost. And so lowest capacity and cost are really the two driving factors behind what makes a hard drive good for Chia. But again, SAS HDDs basically have a ton of extra functionality and customization that are really nice, just for other use cases. I mentioned farming. Once the drives are in the JBODs for the farming setup, there's almost no I/O at all. Each drive basically drives about 0.5 IOPS of total use case, which is like between 7 and 8 kilobytes per second, depending on the drive size. It's like almost no utilization. So the hard drives are idle 99.75% of the time. They do get accessed about every 30 seconds or so. Basically, you have to prove that you're actually storing that capacity. So they have to do these frequent scans, but there's not very much I/O that happens during these frequent scans. So this farming is very, very efficient. And what the drives are basically in this, what they call idle A power consumption, where basically some of the servos disabled, but the heads are in track follow and the motor spinning at full speed. Generally, they have this other power setting called idle B in hard drives, where the hard drives can park the head when it's idle for a certain amount of time. Depending on how many plots per drive you can have a drive that goes into this lower power idle B state and saves a couple watts. But a typical 7,200 RPM drive consumes about 5 to 6 watts for Chia farming, which is great, because if you compare that to something like Bitcoin mining, where a single Bitcoin miner consumes 3,300 watts of electricity, comparing that to one hard drive that consumes about 5 watts, that's very exciting. Now, in the future, of course, SSDs can do this Chia farming at almost no power because of how often, how much time is idle. SSDs can go in and out of these idle states much easier than hard drives can, because they don't have these rotating parts and spinning media. And so that's really exciting for Chia in the future. The other thing about Chia is, there's no data protection required. So plots are all fungible. So once the plots are created, they just have these cryptographic keys. They have what we call a farmer key and a pool contract address attached, and these are public keys that are used to create the plots. And so there's no confidential information, there's no private keys, and there's no, they're all completely fungible. So if you do have a disk that has an error or fails, it's no problem. If you have a drive that is, has a high uncorrectable bit error rate or bad media, not a problem. If the drives already have plots on it, then you likely won't hit them, because you're doing just a very small amount of random reads at a very low IOPS. So that's really great. So this is a good use. Again, one of the key takeaways here is, people are using SAS infrastructure because people can buy this stuff that is used, like old JBODs, that are getting completely new life breathed into them with Chia, because people are trying to find these ways to store lots of drives in a small amount of space at low power. And again, SAS has already conquered this and very mature technology, as Cameron showed, with the the number of exabytes deployed on SAS infrastructure is just massive. So this is a great opportunity for people to be able to reuse the hardware and reuse that SAS infrastructure for something like Chia. And again, there's no need for RAID or erasure coding or backup or anything, because the data is not user data, it's just ephemeral data, where these plots can be recreated if they get lost. But again, it's such a cool use case for old storage, such a cool use case for SAS. It's completely new and novel. There's nothing like this that existed before Chia, especially at the scale that Chia has. At the peak of our network, we hit about 40 exabytes earlier last year. And so this is just a very exciting time for the future of basically being able to reuse storage devices in things like applications like cryptocurrency. So With that, I'm going to turn it over to Cameron to talk about the SAS 24 gig SAS ecosystem.
Hey, thanks, Jonmichael. That's a lot of great information and good tutorial on Chia farming and crypto. So I'd like to just touch on a little bit of what's going on with 24 gig SAS and show you the SAS ecosystem. Here's a quick highlight of the SAS ecosystem components and the vendors that offer products. The companies shown here are members of the SCSI Trade Association, and they've been developing products for many, many years. All of these companies work together at SAS Plugfests in coordination with the University of New Hampshire's Interoperability Lab to ensure SAS products work together in small and large configurations. On this slide, touching on highlights of 24 gig, the items on this slide highlight some of the enhancements made to 24 gig SAS from 12 gig, in particular in the physical layer and at the protocol/block level. The physical layer enhancements include doubling the effective bandwidth from 12 gigabits per second with improved encoding and adding 20-bit forward error correction. What the physical layer enhancements deliver are higher IOPS and bandwidth performance and robust reliability. On the protocol side, on the protocol and block side, the fairness updates help to improve performance across multiple generations of attached devices in larger topologies. This includes SAS and SATA, as well as hard drives and SSDs in the same deployment. Storage intelligence enables more efficient streaming and data management to SSDs, and this translates to improved SSD efficiency and quality of storage performance throughout the topology. SMP priorities also help to improve prioritization of configuration and management communications. And in summary, SAS is a great storage technology for crypto farming and is the preferred interface for Chia. SAS vendors work closely together to ensure interoperability and compatibility between products and configurations from a few drives in a server to architectures with thousands of drives. It has broad support for both SAS and SATA hard drives and SSDs. And to ensure longevity of your storage investment, each SAS generation is backward compatible with 2 previous generations, so you can migrate and update your SAS infrastructure at your own pace. And lastly, thank you for joining us for today's session. Please visit the SCSI Trade Association and Chia at the links on the screen and follow us on social media. And of course, please be sure to rate our session. Thank you very much.